Okay, so now here we are back in the world where things are working properly, and Notepad cubed is now in, which is good. This changed from 00 to 11 in conformance with the Notepad, and just delete me this get on pair / optimize. There are 13 in the list, and that's the correct number. One of the things you might notice, of course, is that the ordering is not the same as before. I don't know if that affects the batch file, the ignoring. Can I ignore %1 and still expect it to be complete in one go? Suppose B and D match. I would have to assume that A and B, A and what else is remaining in that group will get compared. Well, here's an A and C, here's an A and a D. It might still be okay. One go might be enough when this is working correctly. But more to the point, I added in order to do all this, I added a sorting function to, I'll use my fix for this silly thing. I added a sort to the list class. Now, sorting any collection of objects means the following. Now, here I have a unit test because I got curious about something. I wanted to see how well my sort method stood up against the standard, what you would get with a standard list using the standard template library. Now I don't know, let's just do the thing stuff. Probably get rid of it. So if you have a collection of objects, a whole bunch of objects, if this is sorted, let's call it x1, do them labels. It just means that x1 less than or equal to x2, and so on. That is, given any n for all n xn is less than or equal to x n plus 1, these are subscripts, which I could make look nice with that Gmail tags. I don't know if you ever tried it. It's quite fun. If I can get this to come up and get into my email and just take any old draft. Most of these drafts are me trying to make formulas. And this is free, you can install it. If you want to make a map, I don't want it in there. I want to make it go in here. Oh, why not? This thing. No, not that. Yeah, there's one of these buttons. I want to not pop out. Oh, wait. Shift for pop out. No, I don't want that. How do I get in here? It doesn't matter, does it? Sorry, I'm just wasting your time here. Compose. I don't remember this always going here. I want it big. I'll go to my inbox and I'll reply to something. There, that's what I want. If I want to do an equation, go to dollar. And if I wanted x, so then can I use this less than equal? There's a help sign here. Doesn't seem like I need anything special. Let's see. Dollar here. Press F8. That's not what I want. Less than or equal to some. See that here anywhere? Comparisons. This thing has, this website has more help. It'll show you the code for less than or equal. Then comparisons. Here. L and Q. Okay. There you go. So you can make equations. So now I want to say it's sorted, and this is a collection as is set to be sorted if and only if for all logical for all. I wish we wouldn't do those bubbles. You see logic anywhere? That's set theory. Greek letters. These are if you want to do like brackety things. That looks like logic. Wow. Sometimes you can just guess them. Draw X in. Where to find that element of is a little epsilon. Well, this is just wasting time then. But it should be pretty fast. Then, can I choose? I want to choose logic. Oh, come on. I want function. I want colors. That's interesting. And sets, trade, chemistry, physics, stats, sets. Oh, see, I was right. The guess was right. For all x in yes. Then this is true. See how nice it's kind of nice. Said to be sorted if and only if for all x in x. A break of some sort. Comma maybe. Try that. Something like that. So, then it's sorted. And so I wrote it. Now I already had a sort function for my list class before. And it used one or another method depending on what kind of data. But then I realized that function turned out to be doing more work, far more work than is necessary for a sort. Sorting a list is a particularly happy scenario because if your list elements are like this, element 1, those can be anywhere in memory, right? It can be like this, right? There's no the ordering is defined by the way that these things are connected together. The next E1's next pointer points to E2. So there's like that, right? And then E2 points to E3 and so on, right? And that goes over to 4. Right. 24. So that means that you don't need to move the elements around. All you gotta do is change where these arrows point. And what I was doing in my previous version of this is using one of the built-in sorting algorithms. I made an array. The sorting algorithm is called qsort, which takes an array of elements. You got the help here. Qsort is a very well-known sorting method. It takes a pointer to something, right? So you pass it a pointer, which consists of elements. This here indicates the number of elements in the array contiguous, and this here is the width of one element. So if it was T cars, this would be 2, and if it was 10 of them, then this would be 10. So then it can work out how many there are, and then it goes through its sorting routine, and the sorting routine requires you to supply it a function that does a comparison of two elements in the array. Now, these void stars would be elements passed back to your function taken from the array. Now, so now that the comparison function pointed to the element to be compared, key, I think element 1, element 2, right? If element 1 is less than element 2, you're supposed to return a negative value. Otherwise, if they're equal, return 0, and positive otherwise. Very simple idea. And in fact, this qsort is on average, approaches the theoretical maximum speed that a sorting routine can sort. So I took my old method that I had and realized how I could do the whole thing without. I still created an array, but previously I was creating an array of elements, right? Which I would then compare with the comparison operator. But this time, realizing my folly, I still create an array, but I don't create an array of t's, right? I create an array of node pointers to node. So and the size is taken from the list size. Now I got to fill that array up with some data, such that each element in the array is associated with an element in the list. Okay, so therefore now the first element in the array is going to be the head node, and I'm calling that P node for this walk, and this here PR is the array in this TS array that I've allocated. So if I have 100 elements, they get 100 of these, and the elements are pointers to nodes, and a node is this sort of thing. It has a previous pointer, a next pointer. This part is internal, and an actual data object. Okay, so this If it was a string, this would be an entire string. If it was a great big structure, this would be a great big structure. But the node itself, the pointer, is just a pointer. So I make an array of those nodes, and now this might read funny, but if there were an index here, it would look easier to read. If it were an index, and I were going through from 0 to count, all this says is that, right? Because the array elements are pointers. So that's all that is. Star is, of course, as I've said over and over again, has the tightest binding of all operators, or it's on par with the arrow operator. So this here is a unit. That's like the square brackets. So therefore, this increment occurs following the assignment here. This step here simply advances to the next node. Imagine those e's. This follows the arrow to the next node. So now that flattens out the node pointers, not the objects or anything like that, into an array. And what I want to do is sort that array of pointers. Now that doesn't sound like it makes much sense, but it makes perfect sense provided you give it a meaningful compare function to this qsort. Quick Q is for quick sort. So I pass in my array of p nodes. Size here is the number of elements in this array as I'm supposed to give, and this is the size of one element. No, but by this point the array has been sorted. But how has it been sorted? That is what this compare does. It's as the qsort algorithm does its thing, it calls back to find out if element A is bigger than or less than or whatever to another element B. We call them PV1, PV2. Now to clarify, I know that the elements of the array are P nodes, node stars, right? But what this thing passes back to the compare function is not the objects themselves, but pointers to the objects. So back to the help here. The first parameter is a pointer to the key, right? And the second parameter is a pointer to an element. I don't know why they call one key and one element. They're both. I guess it's possible that it might make a copy of an element, so we'll call that a key. Either way, they're both of the same type. They're pointers to whatever the array type of object is in the array. So therefore, this thing PV1 is a pointer to a P node. There's a const here, so I put a const there. Dereferencing that gives me a pointer, constant pointer to a node, or a pointer to a constant node, right? Now, so therefore, if these are node pointers, I can extract the data element by simply using the arrow operator and make the comparison of the data pointed to by these pointers to nodes. Right? Very simple idea. Now, this is all being done without making any new data or moving anything around. All that's happening is, at the end of the day, I'm going to have an array of p nodes that have the property that their data members are ordered. Okay? So at the end, after qsort, where's the sort function gone? Sort. So at the end of the day here, I have an array R. Its members are p nodes, and those p nodes data are ordered. So therefore, I would like the head node of my list now to be the first element of that array. Okay. I know a head node's pre has to be null, so I set that to null. And its next pointer has to point to another pointer to node, right? And I know which one it should be. It should be the next element in that array. Similarly for all the rest. So now I walk through up to everything but the last one. And so that allows these two lines to be safe, right? So for a given index, the previous for that index is the previous in the array, the next is the next in the array, and the tail node is the last element of the array, whose next should be null, and whose previous is the previous. And that's it for sorting a list. Now, out of curiosity, and this is the C++ part, first I made a program called utest to test the speed of the sorting. I'm going to put it under debug. You use release too, but debug. Another bug I found to do with the reason why I couldn't open that file. I don't know. Should I use debug? I only want this program. We'll break this for a sec. I don't want all that stuff. It's utest and common. Now, in my other project uses the standard template library. So I copied this code over there, and I copied the same code. But instead of using a TS list or TW list over there, I use the standard list and call its sort, and I'm hoping that this sort ought to be at least as close to the speed of the STL anyway. I mean, that's the standard, the world standard sorting lists. You know, if you're running some software in a bank and everyone uses the STL, they'll be calling this function. So now this is just a standard list of ints. I've got 5 million objects, and I'm adding a random, some random number in this range. 5 million objects. I have a tick count, which starts here and here. I'm printing out the amount of time it took to build the list, and then I'm going to print out the first 2,000 entries, just to show that they're there. Now this is how you walk through a list, an STL list. You get an iterator, and star of an iterator gives you an element, and plus plus advances. Okay, so that's the print part. Then I say I'm going to sort the list, at which point I reset the counter, call the sort, save off the elapsed time, and then print it out. It's important to get this immediately because this printf costs time and we don't want to include that. Okay, and then I print out the first 2,000 entries. It's the same as my code on the other side. And then print the last 2,000 entries to show that that it's sorted. Okay, I could print out all 5 million, but 2,000 is enough. So I compile this. This is pure STL. There's no, except for this is just printing out dots to show something's happening. Pushback. This is all STL stuff, except for the tick count. There's nothing here from any of my code, other than formatting and printing. This is a printer. So first, we'll try it with the STL and see how long it takes to sort the list of 5 million. I tried 50 million, and that pretty much crashed my machine. Not sure what the limit is, but if it's integers, that's 4 bytes, and I'm going to run this under the debugger, I guess. Then a node is another 4 bytes, and then each node has a previous and a next, and that's another. So it's 12 bytes there, plus the other run, sorry. The other 4, that's 16 bytes. It's trying to start. Maybe I have to pause this thing. Alright, here we go. It's building the list. Okay, now it's going to print the first 2,000 entries. You can see that it's random. About to sort the list, and this size here is taken from the list object. So it certainly has 5 million objects. Okay, press this. Any key. Press the any key. See how long it takes to sort 5 million objects using the standard sorting algorithm. That's quite a lot. I wouldn't have expected it to return immediately, and I wanted to give a big number so that we get a more accurate comparison. And we print out both milliseconds and in time format, minutes, seconds. You'll see if it ever completes. Now, unfortunately, I can't find out any dots or anything at this point because it doesn't provide any callback during the sorting. But it is doing a sort. Be sure of that. I think. Well, it is a lot of objects, right? Now, there's a theoretical maximum, or let's say minimum time for a sort, and the theoretical minimum is something on the order of number of elements times the logarithm of the number of elements. And then there's an overhead amount, which is unknown, depends on the algorithm. But the number of comparisons, the minimum number of comparisons that are required is on the order of elements times log elements, log base 2. And you can kind of see why that would be. Because if you imagine, I don't want to write anything and interrupt this blistering fast sorting algorithm. But try to imagine, use a piece of paper. Imagine if you knew how many comparisons were required in order to sort an object. Okay. The question is, how many comparisons would be required to sort a set with one more element? That is, how many comparisons are required to insert the next element? And the fastest way to do that, to do the insertion, would be to bisect the set and determine if your new element is on the left or the right. Once you've made that determination, with the remaining side, whichever side it is, repeat. Okay. Now that's log base 2 of the number of elements worth of steps. Right? Because you're halving and halving and halving again. So that's a logarithmic thing. So adding another element is on the order of the log of the number of elements, number of comparisons. So not knowing what the actual value is, you know that adding one more element costs that much. So that gives you a difference equation, basically, that the difference between the number of comparisons required to sort n plus 1 elements minus the same for n elements is on the order of log n. If n is a very large number, that becomes a derivative, and so therefore you have basically the derivative of that function is equal to the log of n, and if you know how to integrate, you can integrate log x, then you know the answer. It's not that hard to integrate log x. Anyway, the integral of log x is x log x minus x. So that's why it's an n log n theoretical minimum. This is taking quite a bit longer with the recorder running. Last time I think it was 3 minutes. The hard drive is speeding up. I'd like to show you my wallpaper, but I don't want to disturb the process. It's actually much longer than before. I think it's going to finish soon. No, I should have chosen 1 million maybe. Remember, this is the standard library sort. The one that runs, that is used probably for any commercial product out there. Okay, it took 7 minutes and 50 seconds. Now we're going to print out the first 2,000 entries, and they're all pretty much, looks like the same number, because you would expect that. Sometimes they come out with a few differences. And the last 2,000, they all look the same. Are they the same? No, it changes a bit. See? But you get a lot of repeats because there's so many numbers. Okay, so that's one. It's STL. Now let's try for all else sort. Exactly the same code, but I'm using my things. Again, 5 million entries. Here's I have a spinner, and we'll just let it run. Now it's building a list. Also using that random range. Okay, took that many, a little bit longer to build. I'm going to print the first 2,000 entries. Clearly, they're random, just like before. Size of list, 5 million. Also, it's taking it from the list. Okay, now we're going to do sort. So, hopefully I won't be here too long waiting. Okay, we're done now. So that was 17 seconds. The first 2,000 entries are as before expected. Not much difference, but it's definitely sorted. And that's why qsort is a powerful sorting algorithm, because of its incredible speed. As you saw, significantly faster than the standard template libraries sort. 17 seconds to sort 5 million items. In-place sort, no copies of the items were made. I did this same sort with strings, and put breakpoints to make sure that there, no copies were made. All that happens is the arrows point differently to different places. I don't know what the STL is doing, but it's not an efficient sort. qsort, though, does have its problems. It would work very badly on an already sorted list. But that is something you can check for. And there are variants of qsort that do those checks and convert to a different algorithm, similar but different, in cases where the qsort algorithm would behave slowly. It looks as though the STL is not doing anything like that. But if you want to sort a list, if it's STL, I don't know, you don't have access to the nodes, so you're not able to do what I did there. You can't get a fast sort with the STL. Unfortunate, but if you want to have a fast sort, you have to make your own list class. Anyway, just thought I'd mention those few things. And I'm going to try my new fixed get pairs thing once again to see if I can further reduce these icons down to the bare minimum. And by this point, I don't really care anymore. I'm just curious. I have 4,000, it started at 20 something thousand, and now it's 4,500. Okay, see you.